Hello everybody, and welcome to the overview video for the Statistical Process Control Lab, also known as the Celery Lab. So what I want to do here is just give you an overview of the things you would have done during the lab activity if we were actually on campus. And this will be complemented by stuff that was in the lecture PowerPoint presentation and things that are covered in the lab handout that's been posted on course site. So the premise here is that we are a manufacturing company and our product is celery. And we have a particular product line of celery or a customer that requires 2-inch long pieces of celery. So we're not going to worry too much about the tolerance required by the customer, although it is specified in one question in your handout as 0.050 inches. But the bigger purpose of this would be, as a manufacturer, what is the capability of our process? So what would we be able to manufacture? And if we know that, when a customer comes to us and said, I need 2-inch long pieces of celery plus or minus 1/10 of an inch, we would be able to know with good confidence that we could actually produce that for the customer. And likewise, if somebody came and said, I'd like celery plus or minus 15 thousandths of an inch, we'd be able to tell that customer that yes, we could absolutely do that, or no, maybe we couldn't. So let's get right into it. So our manufacturing process consists of 3 different methods. So we're going to pretend that we start with the simplest method and probably the least accurate method. So these things should be kind of obvious as we go through this, that each of these methods gets progressively better at getting more accurate length pieces of celery and also a tighter distribution, less variation in the length of the celery that I'm producing. So my first method is just freehand. So I'm going to grab a piece of celery. I'm actually dropping my cutting board there on the floor. I'm going to grab myself a piece of celery, try not to cut my fingers off, and I am just going to eyeball what I think a 2-inch long piece of celery is, and I'm going to make 3 of them here as a quick sample. My big knife here is purely for show. And so let's measure these things up very quickly. So I have my calipers here, it's my inspection device. So if I cut these as the production operator, chances are maybe I'll measure them periodically. Maybe I'll have somebody that's right downstream from me measure them. Maybe I'll take one sample every 20 minutes and send it off to a laboratory and have them measure it, and they keep a record. In any case, we have a set of measurements, and then we can use that for statistical process control. So I'm going to measure one up here, see what we get. 1.905. So I'm going to write these down. 1.905, not terrible. .95. Probably better than I should be. And my last one here is 1.98. So sounds pretty good, but again, it depends upon what my customer's tolerance is going to be. Okay, so if I have this type of method, we could imagine that this is very inexpensive from an equipment perspective, right? And we rely really on the skill of our operator to make accurate length celery. So as such, we might need operators that are very good at estimating. And if we consider that kind of a valuable skill, we might have to pay those people more money. We might have to train our employees how to estimate a 2-inch length of celery with good accuracy. Or we may use a little common sense and say, look, we shouldn't really rely on our operator to have to estimate these things. Why don't we provide them with a simple tool to help them out? So the simplest tool we came up with right off the bat is a cutting board that has some guidelines on it. So somebody got the brilliant idea, why don't we just put some marks on the cutting board that are the appropriate length and let the operator use that to guide their estimation. So let's do that. So I'm going to grab myself another piece of celery here. Now each of these pair here are allegedly 2 inches. So first thing the operator has to do is kind of align one end of their celery with one of those lines, and then align their knife with the other end, and then I'm going to make a cut, and then I'm going to readjust, and I'm going to make a cut up here, and then we'll make a third cut. Right, so notice this is a little bit slower, right, because I have to align these things. Right, when I was doing it by eye, I was probably a little bit faster at it, and if I were really good at it, that might actually be a better way to do it. But if I'm not all that accurate, that may not be a good way to do it at all. So what I'm going to do is I'm going to measure these three up, and I have 1.96, so let me write that down. 1.97, 2.05, so I'm a little bit long on that one. Okay, so one might notice if you just look at these numbers here, right, let me flip this around, right, these numbers here for my lines versus my freehand. Now I'm just looking at 3 data points. But it would seem to me that, let's see, these are all a little low, these are all a little high. These are actually a little bit better, right? I'm within 40 thousandths, within 30 thousandths, within 50 thousandths. Here I'm within a tenth, 50, and 2. So I got kind of lucky here, right? Now, one issue with a system like this is you might think, this is a better system. But look at the thickness of my lines. My lines have probably about 1/8 of an inch thickness to them. And so the question is if I'm the operator, where exactly should I line up my piece of celery? Should I put it just on the inside and cut inside to inside? Should I put it on the far side and cut far side to far side? Or should I try to line it up in the middle? Right, so there's inaccuracy. While this might seem a little bit more precise on the surface, there's some inaccuracy still, some judgment on the part of the operator as to exactly how they should line that thing up and exactly where they should decide to make their cut. And also, unless I'm right above this, I might just get a little, I guess, parallax error, right, in trying to estimate where my cut is supposed to be. So there's still some error, or some room for improvement, I guess I should say, in this method. The other thing that ought to be checked is that these lines are actually accurately placed. So I'm measuring here, let's see, I'm going to try to take a measurement as best I can inside to inside on those lines. And I'm actually already over. I'm at 2.025. So even the inside to inside measurement is going to make my celery a little bit long. If I come over here and check my other one, right, about the same thing. Actually, this one's a little bit short, right? So that set is short there. Now, I've made these a long time ago. I may have done that on purpose, right? One thing you should always do when you have any type of fixture that you use, and this could be considered a fixture, even though it's just lines on a board, is you need to check that you have the correct fixture and that your fixture is actually accurate. If you have an inaccurate or poorly adjusted fixture, that's going to be a source of systematic error. If you follow this thing, here you're going to be always a little bit short. Over here, you're always going to be a little bit long. Okay, so accurate fixtures, very important. So let's try making one more improvement. Dig this thing off the floor here. All right, here's my last cutting board. It's actually made by the Easter Island Cutting Board Manufacturing Company. If you get that, right, Easter Island. And what I have here is a set fixture. So what I'll do is I'll put my celery in here, right up against that stop. And then I'll take my knife and I will draw my knife along this groove, or I'll align it in the groove, and I'll make my cut using that groove. So I'm going to make one. It takes me a little long to fish it out of there. Right, I'm going to make a second one, making sure not to put my fingers across there. And then I'm going to make a third one, and then we'll measure these up and see how well this particular device did. All right, so I'm going to flip this around to make me some measurements. Okay, 1.995. That's within 5 thou. Now that sounds good. I may have just gotten lucky. Who knows? Let's check out some other measurements here. Okay, this one's a little bit over, 2.025. And then my last piece here, my third sample. And again, we're just doing these just for a little bit of anecdotal evidence on each one. That one's money. Right on the money, 2.000. Now notice, if I squeeze a little bit harder, it's 5 thousandths shorter. If I turn it sideways, right, it's a little bit short. And I'll come back to this in a second. So this one I'm going to say was right on the money. Right now I'm being a little bit sloppy about how many decimal places I'm reporting, but I'm using calipers, so I could write down to the nearest thousandth of an inch. All right, so this actually looks pretty good. I'm within 5 thousandths right on the money and within 25 thousandths. So just based on this little data set of 3 each, it's obvious that my fixture certainly is a little bit more precise and accurate than the other 2. Right? Not enough data here maybe to make a really good decision on those 2. And I would say that I actually got pretty lucky on the freehand ones. I actually was doing another version of this video earlier, and then the sunshine came into the room and I had to stop. But I was off by over 1/10 of an inch on every one of those measurements. So I actually improved my estimation from take 1 of this video to take 2 of this video. Right? And that's where operator experience, right, is pretty valuable, especially in a very manual process like that. Okay, so the same thing applies to this fixture as applied to the lines. I need to make sure that my fixture is accurately set up so that I'm not making incorrect pieces of celery with some systematic error. The other potential for error I have is this gap that I run my knife through. It is a finite gap. I could have some slop. Actually, you can see there's a little bit of wiggle between my knife and that gap. So that is room for error. Should I run my knife across this side, push it up against this side, or should I pull my knife up against this side? I'm probably going to get a little variation in length if I move it one way or the other. So there might be a little bit more improvement that I can make to this fixture. Okay, so that's pretty much it for the fixtures. The last thing I want to point out is my measurement method. So if I grab a piece of celery, most of these pieces of celery are a little bit off. They're not perfect rectangles in silhouette. There's some angularity to this cut. And so the question is how should I make this measurement? Should I be trying to measure the longest length, the shortest length, something right down the middle? How much pressure should I apply, right? Celery gives pretty readily. So if I squeeze down on my calipers, I can vary my measurement probably 5 or 10 thousandths pretty easily. So however I'm going to measure this, what I want to do is I want to standardize. I want to make sure that everybody that's inspecting knows exactly which measurement is the critical measurement to take during the process and how exactly it should be done. And just as importantly, I want to make sure that my customer follows that same procedure. Because if we're measuring it in 2 different ways, I may think that everything I'm sending my customer is good product. When my customer gets it and measures it in their way, they're going to think that maybe it's not so good. And then there's some conflict that can arise there. All right, I think that's about it. So last year, some seniors cut up a whole lot of celery in the shop. They recorded some data, and we've put that data up on CourseSite for you guys to download. I'll get my hands out of the video there. For you guys to download, and everybody's going to use that data to create control charts for each of the 3 processes, and hopefully those control charts will support our intuition as to which process might be better, kind of in the middle, or the worst. All right, have fun and good luck.